in between any of the new point is been added, then that point will be considered as A. Okay. What is KNN? KNN, as we know it, is none other than K nearest neighbor algorithm. There is no chance of might be, there be, nothing. It is must and should, a true case and a false case. Not spam in the sense actual correct messages. It is considered as truly negative. Hello everyone, I welcome you all to the third session of Unit 3. That's under Fundamentals of Data Science, and Unit 3 is all about classification. Over here, my name is Deepa Kutnikar. I'm working as an assistant professor on the Department of Computer Science, Vidhyaashram, Temple of Excellence, MYSURU. Let's move forward and see what are the things that we have defined or discussed in our previous session. That's in session 2. Yes, we have discussed the things regarding base classification. Then we did discussed the rule-based classification. Also, we did understood what is lazy learner's algorithm. So these are the things that we have discussed in our previous session. Let's move forward and understand what is the agenda of today's session. In today's session, we will be understanding one more algorithm, which is called as K nearest algorithm, or oftenly it is also called as K nearest neighbor. Great. Later, we do also understand the metrics for evaluation with respect to classification. Then there is something called as confusion matrix. Yes, we do understand these things with respect to today's session. Alright, let's start our session and understand the first algorithm of today's session, that is none other than K nearest neighbor algorithm. Alright, let's start understanding with what is KNN. KNN, as we know it, is none other than K nearest neighbor algorithm, and it is one of most popular lazy learners algorithm that is available. It classifies a new data point with respect to the majority class among the nearest K neighbors. So, the K nearest neighbors. Let's understand how this KNN works. So, initially it starts with choosing a value of K, and the next step is step 2. Under step 2, what happens is the distance between each nearest training points are calculated. So that's our second step, and the third step is none other than selecting the K nearest neighbor. So with respect to the available neighbors, we will be selecting the nearest neighbor out of those available neighbors. Then further, in step 4, we will assign that class as most common among those available classes. What is it being assigned as? Has a most common class. Please note that it is being assigned as a most common among the available neighbors. So this is the process that is being followed under KNN. Up next, let's move forward and understand the distance measure. So we can't directly say that like this is the measure or this is the distance between every neighbors, right? So there should be some criteria or some terms for that, isn't it? So let's understand that terms. So this is a expression or a formula that is being utilized to calculate the distance in KNN. Thus, the expression is square root of summation of xi into yi of square. Now, what is this x and y? So, these are the neighboring points. So, if I am considering the first neighboring point and the second neighboring point, and in order to calculate the distance between these two first and 2 points, we will consider the first has x and the second has y. So, similarly, if I want to move at the next, that is third, fourth, again the variables keeps on changing or updating. So this is the formula, and this formula is very similar, or we can term it as a Euclidean distance formula, which is considered in order to find the distance between the K nearest neighbors. Thus, now let's understand this in a better way with an example. Let's consider we are having 2 classes and it is named as A and B. Alright, and now the value of K is also considered as 5, okay? And now among those 5 nearest neighbors, we can assume that the first 3 can be allotted to A and next 2 will belongs to B. So this is a small representation of this expression, or the example states that how the nearest neighbors are being predicted. Clear? Let's move forward, and there is something like there is some measures through which we can easily ensure like what is the k value and how this k value is being allotted or considered. So let's move forward and understand that also. If in between any of the new point is been added, then that point will be considered as A, okay? And now let's see how to choose the value of K. If the value of K is very small or negligible, then we can assume that it is very sensitive to noise. What if the K value is large? At those cases, there will be a smooth boundaries, but it may ignore the local patterns. With respect to this, we can note that the best value of K is usually chosen using cross validation. Yes, we have to cross verify the K values, whether it is a small one, it is a large K, then what is its impact, and the main application for which we are going with this K algorithm. So it has to match that end application also. So in that way, we can select the exact or the best value of K. So this is how we can choose a value of K. Let's move forward and understand the advantage of KNN. This algorithm is simple and effective. There is no training required and it works very well for multi-class classifications. So these are the advantages. As we did understood advantages, let's move forward and understand its disadvantage as well as the applications. The main disadvantage of this is the process is very slow if we consider a large data set, and it requires large memory too. It is also very sensitive to any of the irrelevant features which are available along with that neighbors. So with this, the performance decreases if it has a high dimensional values. So these are the disadvantage. Moving with applications. So as we can see, these are the few applications like this KNN is used in data mining. It is also used in the machine learning as well as in the robotics and the sensor networks. So these are the various applications in which this KNN algorithm of classification is being utilized. Now we are done with the algorithms which are available in order to do the classification. Let's move forward and understand what are the different metrics that we can utilize with respect to evaluating the classifier performance. Exactly, performance plays a key role, correct? As we know, the performance plays a very important role or a key role with respect to any of the classification or any of the applications, right? So that's why now let's understand the various terms that are included in order to rate that performance. The first term is none other than the precision. So this is the first metric which shows or says that how accurate is our predictions are. So it gives us a knowledge of positive predictions. Or in simple case, we can say that this gives an exact or accurate answer of the positive prediction. So let's consider that there are multiple positive predictions available, and out of those positive predictions or cases, how many are actually positive? So this is being provided by this precision. All right. So with respect to this, in order to measure precision, there is a formula which is none other than precision equals TP. TP is none other than true positive. What is it? True positive. True positive divided by true positive plus false positive whole divided by the text. What is the text of that precision we have considered? Then it is also calculated through one more example or one more formula, that is none other than fractional of the true positive into true positive plus false positive, or the precision can also be considered or calculated by this formula, that is none other than true positive plus false positive into true positive. So whatever the formula we consider out of these, it provides a exact precision value. All right, let's move forward and see a basic example for this precision. Yes, over here we know that TP is none other than true positive, which gives us information of correctly predicted precision, and the next one is FP, which is none other than false prediction, which gives us a information of wrongly predicted positives. Now let's consider an example where a model is predicting 50 students will pass and only 40 will actually pass. Now out of this, how to calculate the precision or the exact precision? So we can consider this 40 has a true positive, correct, right? So actually pass. So this can be considered as a true positive, and this 50 can be considered as true positive plus false positive, isn't it? What is this been considered as? True positive plus false positive. Thus, now let's calculate what is the percentage of precision. So we know that the precision is none other than true positive whole divided by true positive plus false positive, correct? So it is 40 by 50, which gives us an answer of 0.8, which is none other than 80%. So the precision of this model, we can say that it is 80% precise, and the false positives are very less. Great. Let's move forward and understand the second metric with respect to performance of classifiers. So that is none other than the sensitivity, which is also called as recall. Recall will tells us like actually what is the number of positive cases that were actually predicted, and it gives us an answer of like out of all actually positive cases, how many cases were actually correctly identified by the model. So it answers this. Let's see a simple formula for recall as well. So it is none other than true positive whole divided by true positive plus false negative, or directly text of recall, or we can also consider it has a fractional of TP, that is true positive into true positive plus false negative, or it can also be considered as true positive plus false negative into true positive. So let's move forward and understand this with the example 2. So true positive, this we have already learned, like it gives us a exact positive cases. Now with respect to FN, that is none other than false negative, it gives us a wrongly predicted cases. Okay, let's see an example. If there are 50 actual past students and the model correctly predicts 40 of it. Now let's put a formula here. This is considered as true positive and the 50 are considered as true positive plus false negative. True positive plus false negative, isn't it? So let's put a formula, that is 40 by 50, and it gives us again an answer of 80, and it is none other than 80%, which says that there is a very low false negatives. Alright, let's move forward and understand a basic difference between this precision and recall. So let's start understanding it. First one, precision. What does it measures? So it measures the correctness of the positive predictions, and the recall, so it has the ability to detect all the positive cases. Clear? Please note the difference. Later, the precision is used or utilized whenever we want very less false positives, and this recall is being utilized whenever we want very less false negatives. So this is the difference, false negative, false positive. Okay, please note that false positives are very less when under precision, and false negatives are less at recall. So this is the basic difference with respect to these two. Alright, let's move forward with the next topic, that is none other than confusion matrix. So yes, with this name, don't get confused. It will not make us confused, but it helps us in making or understanding the things in a better way. Thus, there are various classification models, correct? Now, with respect to these classification model, we had many metrics and we have the procedure of its own, isn't it? Now, it will become important to note or coin the difference between these different algorithms which are available with respect to classification, correct? And in this case is what our confusion matrix helps. So this matrix is just a table-like representation, but it gives us a clear information regarding the performance of the confusion models. and it shows us exactly the number of correct as well as the incorrect predictions that are made by the model compared to the actual outcomes, So now let's see how a basic confusion matrix is been created or generated. Again, it has to go with few terms like TP, FP, FN and all. TP is none other than true positive and TN is none other than true negative. But how to construct this? It is very, very simple. First, let's write the prediction, and under that we will be writing positive, negative, again positive, negative. And let's move forward. If both are positive, then if both the row and a column is positive, then we can surely say that it is truly positive. Okay. Similarly, if my row is positive and a column is negative, then I can say that it is false negative. Clear? Let's move with negative. If my row is negative and a column is positive, then I can coin it as a false positive. Similarly, if both are negative, then I can coin or term them as truly negative. Clear? So this is a basic matrix structure for binary classification that we can consider. Clear? Now let's move forward and understand this TP, FN, FP and TN in a depth way. Okay, let's start with true positive, which it actually gives a positive value and the model predicted positive things. We can also say that it gives us a correct positive prediction. Next is true negative, which is the next one. That is, the next is true negative. Okay, so true negative means the model predicted negative, or it is actually negative and it is a correct negative prediction. Clear? So this is the meaning of our TN. Okay, there is no chance of might be, there be, nothing. It is must and should, a true case and a false case. Clear? So let's move forward and understand next two cases, that is FP, which is nothing but false positive. The model predicted positive and actually it is a negative thing, but wrongly positive prediction or wrong positive prediction, and it can also be called as type 1 error. Okay, please note that it is generally considered as type 1 error. Up next is a false negative or a FN. The model predicts it has a negative and actually it is a positive one. Okay, it can also be considered as wrong negative prediction, also called as type 2 error. Clear? So this is nothing but our FP, FN, TP, TN. Clear? Alright, let's move forward and see a simple example for this. Let's consider our email inboxes. So in our inbox, definitely we will be having spam mails and not spam mails, right? So let's see the classification of confusion matrix with respect to these two considerations, that is spam and not spam. So under spam, initially we are having 80 mails, okay, and under not spam, that is spam, not spam, we have 20 of emails. Thus, we can consider this as TP, that is truly positive, and spam and few not spam are considered as false negative. Clear? Then not spam and spam mails, that there is a confusion and it can be considered as false positive. Further, not spam in the sense actual correct messages, it is considered as truly negative. Okay, so this is a simple classification of a confusion matrix which gives us a clear picture of how many spam are there, how many spam but not detected are there. So how many spam but not detected are here? Yes, it is none other than these 20. Okay, these are spam but not detected, and this 10 are considered as not spam but are by default or by miss they have marked under spam. Okay, and the next 90 are truly negative, which says that it is correct and it is not spam. Thus, let's move forward and understand the importance of this confusion matrix. This confusion matrix will help us in computing various metrics that are available with respect to the classifications. So the first metric, we know that it is none other than precision. So in order to calculate precision, this confusion matrix will help us. Next, second metric was none other than, do you remember, it is none other than a recall. Yes, in order to calculate that also, this confusion matrix will help. Further, the accuracy of the classification can be find out using this confusion matrix, then something called as F1 score, which is a final score. So this score can also be calculated based on this confusion matrix. Thus, this completes our unit. So let's meet up in the upcoming unit to learn. Thank you.